Welcome to the Deep Dive. Today we're digging into Google's latest TPU, their 7th generation called Ironwood.
That's right.
We've got some good material here detailing what it is, why it's a big deal, and sort of where it fits in the whole AI hardware landscape.
Yeah, and the goal today really is to pull out the key insights, right?
Yeah.
What are the aha moments about this chip for someone wanting to understand its impact quickly?
Exactly. Cut through the jargon. So Google keeps talking about this age of inference. How does Ironwood tie into that idea?
Well, it's interesting. They're pushing this concept where AI isn't just reacting, it's proactively giving you insights, maybe taking actions. And Ironwood fundamentally seems built for that. It's designed to run those huge, already trained models very, very efficiently. Think less about training, more about using the AI at scale.
Okay, using it fast. So let's talk specs. What kind of power are we actually looking at here?
The numbers are pretty eye-watering. Each chip apparently hits 4,614 teraflop PS using FP8 precision. And when you put them together in a full pod, you're looking at something like 42.5 exaflop PS. Just massive scale.
Exaflop S. Wow. But I heard the memory is the really big story.
I think so, yeah. That's arguably the standout spec. 192 gigabytes of high bandwidth memory, HBM, right on each chip.
192 gigs. That's huge. How much more is that than before?
It's 6 times more than Trillium, the previous TPU generation. 6 times.
Whoa. So what does that actually do for AI? Why so much memory?
Think about these giant AI models, like the big language models. They have billions, even trillions of parameters.
Right.
Having that much memory directly attached means the chip can hold more of the model's brain, basically, right there. Less fetching data from slower storage.
So faster, more coherent thinking.
Exactly. Faster responses, potentially more complex reasoning in things like chatbots or, future versions of search. It's about reducing bottlenecks for these really big inference tasks.
And it's not just the amount, but the speed, too.
Precisely. The bandwidth is also way up. 7.2 terabytes per second per chip. That's a 4.5x jump. And data gets in and out much faster.
Okay, so huge memory, fast memory, anything else?
Yep, the interconnect, how the chips talk to each other in those big pods, is also 1.5 times faster. Crucial for scaling efficiently.
Right, you need them all working together.
And maybe the kicker? They claim twice the performance per watt over Trillium. That's huge for operational costs in data centers.
Better performance and more efficient. Okay, that's impressive. Now, Google's been building TPUs for a while. How does Ironwood fit in that evolution?
Yeah, it's quite a journey. The first TPU way back was purely for inference running models. Then V2, V3, V4, V5, V6. They all added training capabilities. They became more general purpose AI chips. Think V3 adding liquid cooling, V4 boosting the interconnect, V6 powering Gemini.
So they went from just inference to training and inference.
Right. But now with Ironwood, it feels like they're circling back, creating a highly specialized inference chip again, but leveraging everything they've learned. It's optimized for running models, not necessarily training them from scratch.
Interesting. And these chips aren't just research projects, right? Google uses them heavily internally.
Oh, absolutely. This is core infrastructure. TPUs power huge parts of Google search, like RankBrain and the new generative experience stuff.
Okay.
They're in Google Photos for image recognition, Google Translate, AI features in Maps and Gmail. And of course, there are big research models like Gemini and AlphaFold run on TPUs. It's deeply embedded.
So it directly impacts the Google products we use every day. Now, the elephant in the room, Nvidia. How does Ironwood compare?
Yeah, that's the big question everyone asks. Performance-wise, in FP8, Ironwood looks competitive, especially against the H100.
And that huge memory.
That 192 gigabit matches what Nvidia announced for their next-gen Blackwell B200. So Google's right there, or even ahead, on memory capacity per chip right now.
But Nvidia has strengths too, right?
Definitely. Nvidia generally leads on interconnect bandwidth, how fast their chips talk across a system. And crucially, their CUDA software ecosystem is incredibly mature and widely adopted. That's a big advantage.
So it's not necessarily an Nvidia killer, but more like a specialized tool for Google-specific needs.
That seems like the right way to think about it. Ironwood looks laser-focused on large-scale inference, particularly for the kinds of massive models Google deploys internally and likely offers via cloud. NVIDIA's GPUs are often seen as more general-purpose AI workhorses. Different design philosophies, perhaps.
Okay, that makes sense. So, boiling it down, what are the key takeaways on Ironwood?
I'd say 1, its strong specialization on inference. 2, that massive leap in on-chip memory capacity and bandwidth. And 3, its strategic role inside Google for both their products and cloud AI offerings. It's custom silicon designed for their scale.
Got it. So looking forward, we're seeing this intense specialization. Inference chips like Ironwood, training-focused hardware, this focus on system integration. What's the next big challenge? What bottleneck might the next generation of AI hardware need to break through, something maybe we haven't even touched on?
That's a great question to ponder. It really highlights how fast this field is moving and where the next architectural innovations might lie. Lots to think about there.
Definitely food for thought. Thanks for breaking down Ironwood for us.
My pleasure.